Welcome back everyone. Today we are going to take a look at the logic behind the master chip from tutorial 1. These sort of logic deep dive videos are not required viewing, so if you just want to move on to tutorial 2 then you're welcome to do so, but if you want to understand the logic behind what all of this is doing, then this is the place to be. So when you first imported the master chip, you may have noticed that you have 4 sculpts. We will run through the reasons for these in a moment. The first little sculpt here is essentially the imp. So as you move your imp around the screen, this little block moves along with it. So we'll take a look at the logic behind that now. The first thing you'll notice is a control sensor. This is mapped to some transmitters which are just transmitting button presses. We'll use those later on, but in this control sensor there's some important settings in relation to the imp. So first of all, the possession mode is following the imp. This essentially allows motion controls to move the imp around the screen. We also have allow imp during possession because we want to see the imp, and we are force possessing the object. Key point here being that we are force possessing the little block, not the puppet. Control sensor is controlling the block. We also then have essentially the imp turned on, so the visibility, so you can see the imp whilst you're moving around the screen. If you were wanted some sort of pointer or a crosshair or something like that, which I am intending to add as a feature of this master chip at some point, but haven't got to it yet. You'd want to hide the imp. So that's it for the control sensor, pretty simple really. We also have in here a variable which is powering the control sensor. There are certain points in the game where you won't want the user to be able to move the imp, use the imp. Rather, you can still move the imp, but you don't want to allow the buttons. So that's what that's for. And then finally down here we have a tag, which is essentially just a way of finding the imp on screen. And then here we have the imp user interface, which we will take a look at now. In here we have essentially the scene space transform output coming in from the tag. We then split that to get the position. Obviously the scene space transform has position, orientation, scale. We just need a position. We're then splitting that again to get the XYZ coordinates of the imp. And we also have a global settings chip here. So the global settings chip in the outputs will output the current camera's scene space transform. So what we want to know is where the imp is in relation to the camera. So we're doing the same here. We split it out, we get the position, orientation, but we only want the position. We split it again to get the XYZ, and then we are doing some very basic math. We minus the imp position away from the camera position. This results in essentially a value from -2 2 to +2, +2, with 0 being in the middle. So plus 0 minus. Then we have a selector based on the outcome of that math. The way selectors work, if you've only got 2 inputs, anything above 1 will move to B output, anything less than 1 will stay on the A output. We then have the UI themselves. So the reason we have this is if the imp is over here on the right of the screen, you don't want the user interface to be hanging off the edge of the screen so you can't see it. So we flip it around and it goes to the left of the imp, and equally if we're over here, you don't want the left UI because it will be off screen, so we flip it to the right UI. Then if we have a look at the user interface itself, so in here we have a wireless receiver. This is checking if the inventory is open. We'll get to inventories in later tutorials, but that's what it's there for. If the inventory is being used, we move it to the next slot, which will use this microchip, but when we're not using the inventory, we use the standard pointer microchip. And inside here is a bunch of variable getters. We are essentially checking whether something is inspectable, inventoriable, usable, or talk toable if it's an NPC character or something like that. And based on the values of them, we then display the various text on screen for the user to see what you can interact with. And if we just turn those on, you'll see that they're there. That's it really for the imp chip. Hopefully fairly simple to follow. And we'll move on then to the camera, screen and imp functions. So this chip houses most of the logic actually for this, and we start with the camera and sound chip. So obviously your camera is your camera. We then have a couple of tags in here. So again, these are for the inventory, which we'll cover in a later tutorial, but eventually location is in front of the camera. Default inventory is behind the camera, so when you're using the inventory, it will essentially teleport to the front of the camera, and when you're not using it, it hides it behind the camera. We also have, if you remember from the first tutorial, the trigger zone, which is looking for the player, which then powers the rest of the logic. And then finally in here we have some speakers. You don't have to use these. I use them because I didn't want positional sound, so I wanted to output all of my speakers, all of my sounds to these speakers. Then what we have in here, so once we've detected the player, obviously we then power some additional logic, and what we can do if we need to, and certainly when we get to a point where we're adding more screens, we might want to output a default destination for the puppet. So this is just a a switch which you can turn on and off depending on whether you want to output a default location. This is then the default location logic. So we first of all we detect whether the player is in this screen. We also then check to see if the switch is turned on. If it is, we just add 1 to a counter to determine whether this is the first time the player has entered the screen, because what we don't want to do is power this tag whilst the player is always detected. So we just want it to do it once, and then we power the follow me tag. So it's currently set to its default position. So if you wanted the puppet to move to a specific location when you first load the screen, you use this. When you press play, she'll automatically go to the default location. You don't have to use those, but it is useful when we get to the point of having more than one camera and more than one screen. Then what do we have? So we have here the imp pointer receive. So this is just receiving the button presses that were on the imp chip we looked at earlier, and what we're testing for here is, first of all, is the player detected? Is the player within the screen? If they are, and then we are pressing the X button and the inventor is not open, so we don't want the player to move around the screen when the inventor is open, so we check for that as well. So if we're detected and we're pressing the X button and we're not using the inventory, then we power the emitter for the follow me tag. So in here is the emitter for the follow me tag. So this is the follow me tile, I guess we'll call it, and this is what's emitted onto the floor for the puppet to follow. So if we're detected pressing the button and not using the inventory, we power the emitter. So this chip here has a laser scope. This is following the imp, so the little sculpt. Whenever that's moved around the screen, the laser scope follows it around. We then determine whether we've hit something. So this is looking for the target, which, if you remember from the tutorial in 1, is what we labeled the floor. So we need a target for this to find, in which case, in this case, is the floor. So we determine whether we've hit something. We determine if we've also pressed the X button, and we're determining whether we're not overriding the default behavior, which is the emit on X press. If we're doing those things, we then power the destination tile emit, and this just emits the destination tile to the location that the laser pointer hit. There are occasions, as I say, when you want to override the behavior of pressing X, and that could be on the first scene entry, so your default location, or it could also be if you've got more than one screen, you specifically want to emit a destination tag outside of the viewing area of the camera, and if you're doing that, we need this logic here, and it looks kind of complicated, but it's not. So this chip here has 4 switches, and they are to tell the logic whether or not you have a screen off to the right or off to the left or up or down. So if we were to say had the screen over here, and when you moved over there you wanted to move to the next screen, this is where you would tell it to do that. So you would say there's a screen to the right by flipping the switch. There's then a trigger zone which detects whether or not the imp pointer is on that edge of the screen. So if we've got a screen to the right and the imp is over here on the right, then we want to power this logic. So what we do is we check to see if there's a screen to the right, we check to see if the imp is within that trigger zone. If it is, we're just turning on a a text box, which is just displaying an arrow up, left, and then down there at the bottom. And we're also checking if we're pressing X. So if we're over here on the right hand side of the screen and there's a screen over there and we press X, this would power a new tag, which is in this case right of the screen, which is over here, and it will output the scene space transform, which will then be inputted into the override destination node, meaning that that position over there will be where follow me tile is emitted, as opposed to on the floor. And finally, so we have the last sculpt in the set, and this sculpt is effectively an emitted object that checks to see if something is interactable, and the logic for that is in here. It's very simple. We have another laser pointer which is getting the imp position again, and we're emitting the interactable ball into the location where it's been hit. What we're also doing actually here is ensuring we turn this off if we leave the scene. What we don't want the emitter ball doing is, if we're in a different scene, it doesn't need to be still in this screen. So that is it really, I guess, for the master chip. Hopefully all that makes sense. If not, feel free to ask questions in the comments, and I'll try and cover anything off that I may have missed. Thank you.